Hello, my name is Pavan Shah, and in this demonstration, we're going to talk about how platform teams can enable data scientists in their organization to spin up Jupyter Notebooks and machine learning pipelines on demand. As part of the setup, the platform team has already configured the Kubernetes cluster, installed Portworx, and configured Pure FlashBlade as the artifact and dataset stored. Once Kubeflow is up and running, data scientists can just access the Kubeflow UI and spin up Jupyter Notebooks on demand. This translates to running a Kubernetes pod and a persistent volume under the covers, but the data scientists don't need to worry about anything on Kubernetes. Once they are happy with the model and pipeline development, they can use Kubeflow pipelines to actually run experiments against the raw data, like against the dataset. As part of the pipeline, they can have different stages in the DAG or directed acyclical graph, where they can get raw data, they can prep the data, they can train their models and then run validations on the models. And at each stage of this process, they can save and download data from that FlashBlade S3 bucket. Users can alternatively also just store data on a read-write many persistent volume on the Portworx storage layer. So it saves them a lot of time downloading large data sets. So now let's put on our data scientist hat on and navigate to the Kubeflow UI and spin up a new Jupyter notebook. As you can see, the process is really easy. After navigating to the Kubeflow UI, all I need to do is click on new notebook, give it a name, and then select whether I want a Jupyter Lab notebook, Visual Studio Code, or RStudio as my preferred IDE. I can also specify a custom container image. This is to avoid all the different version discrepancies and make sure that the data scientists across the team are using the same versions of different packages. The data scientist at this point can request for the required number of resources, CPU, memory, GPU, and storage. And because this is running on Kubernetes will orchestrate these pods or containers on the right nodes which have enough resources. For the workspace volume, we're going to use a block volume from the Portworx storage layer. But for the data volume, we're going to use a read-write many persistent volume, which will allow me to share all of my work with other members on my team or across different other notebooks that I create from the Kubeflow UI. This makes it easy for people to share work across teams, across data scientist teams. So once I'm happy with all the configuration, I'll just look at one last advanced configuration and allow my Jupyter notebook to have access to the Kubeflow pipelines component inside Kubeflow. Once that's done, I'll hit launch, and this spins up the necessary pod and persistent volumes and service objects on my Kubernetes cluster. Again, platform team has already done all of the heavy lifting for me as the data scientist. Once the notebook is ready, I can hit connect, and I'll be greeted with a familiar interface that I'm used to if I'm deploying Jupyter notebooks on my laptop or on my own on a VM instance. As you can see, the Jupyter IDE gives you access to a file explorer on the left, where you can keep track of all the different files that you have on your PVC, and a terminal session and a browser-based IDE on the right as well. Just let's make sure that we have the right set of packages. Since this is a golden container image that I spun up this notebook from, I can rest assured that all the different packages that I need for my work are there. I can create a brand new notebook, or I can just upload one of my previously started notebooks, and that's what we'll do as part of this demo, right? Using this notebook and this notebook file, what we're going to do is create a DAG configuration that can be used in Kubeflow pipelines. As part of that DAG, we'll create different stages that match the initial architecture diagram that we saw. Includes phases like getting the raw data, prepping the data, training the model, and running validation. So in the first stage, we are just going to pull down the raw data from our S3 bucket that's running on our pure FlashBlade system on-prem. Once that's done, we'll split it into Xtrain, Ytrain, Xtest, and Ytest. Again, this is a simple model that we are training. It's the digit recognizer model. Again, we're not focusing on building custom models. We're just focusing on how platform teams can make lives of data scientists easier. As the second stage, the reshaping data, we'll again pass it the access key and secret key for our FlashBlade bucket, and then pull down the files that I need and then reshape that data. So I'm going to split up my Xtrain and Xtest, normalize that data, and then upload it back to my S3 bucket. So once that's done, next function in my notebook is building the actual model. Here we can set a couple of parameters that can be changed when we do hyperparameter tuning during the experimentation phase. But as part of the model building, we import all the different libraries that we need. We train the model using our training data set. And then once I'm happy, I'll also upload the model, the trained model to my FlashPlate S3 bucket. So again, lots of lines of code. We'll put this code on GitHub if you want access to it, but this is the open source digit recognizer model that I'm using for this specific demonstration. Once our model training is done, the final phase is model serving. And for this, we'll again import a lot of Python modules and SDKs that are needed. And then Kubeflow gives me a couple of options, right? Since we gave this notebook access to Kubeflow pipelines, I can immediately instantiate a pipeline instance once I hit run on this notebook. Or what I'm doing in this demo is creating or generating a YAML file that I can later upload to the Kubeflow UI and then create that pipeline. I want to make sure that everything looks good before I actually create that pipeline, because that can lead to, like, if I'm just changing things, I don't want 10 instances of a pipeline that are not really useful to me. So once all of that is done, I'm happy with the code that I've written. I can just hit play on this specific cell, and it generates a YAML file and saves it on my persistent volume that's backed by Portworx. So once that's done, I can give it a few seconds for it to go through all the different steps and generate that YAML file. Again, this is not where I'm actually training the model. This is just where I'm creating the DAG to run experiments on. So as you can see, the output file looks like a Kubernetes YAML file with workflow as the CRD, or custom resource definition. Again, as data scientists, don't need to worry about any of this. I can just save it as a YAML file and then use this and upload it to the Kubeflow UI to create a new pipeline. So let's go to the Kubeflow dashboard again, navigate to pipelines, and then we'll click on upload pipeline button. Here we can give it or upload the file that we generated from the last notebook. And it automatically fills up the pipeline name and the descriptions if we gave it one. Let's hit create, and it creates a pipeline. As you can see, it gives us a neat little summary. It gives a visual representation of our graph. As you can see, we are like getting the data, reshaping the data, training the model, and then serving the model. Once the pipeline looks good, I can share it with other members on my team to run their own experiments, or I can run my own experiments using the pipeline. So let's create a new experiment, and then each experiment instance can have multiple runs. So we'll create our first run. We'll do the number of epochs as 1, and then optimizer can be set to Adam. And then once I hit start, it basically starts going through the DAG that I have configured as part of the pipeline. You can use the Kubeflow UI to monitor the logs. So as part of your notebook, you had specified that it should output certain things into logs. You can actually use the Kubeflow UI to look at all the different logs that are being generated for you as part of all the different stages. So if you look at the reshaping data, it gives me output for log output for that stage. And then if you look at the model building stage, it gives me an output for the model building stage as well. It shows me all the files that have been uploaded to my S3 bucket. And since epochs was set to 1, it showed me that it ran through all my training data and validation data once. And then finally, once model building is done successfully, it goes to the model serving phase. And then once serving is done, you can actually use this UI to look at the output, like run output. So you can look at your model performance and the model loss. So model accuracy and model loss percentage. So model accuracy was 97.68% after training my model on the data one time. Let's do a second run, because maybe I can get a higher model accuracy number. So let's create a new run for the pipeline that we created earlier. And in this case, we'll set the number of epochs as 5, keep the optimizer to Adam, and then hit start. Again, it goes through all the same stages in my DAG, and then in the model building or model training phase, it actually runs through the dataset 5 times. I can still use the Kubeflow UI to monitor the logs and see it using or running through the dataset 5 times. So just click on the logs menu, and then here you can see that it's right now it's 1 of 5, but then because of the magic of video editing, we'll see how quickly it goes through all the different 5 epochs and trains my model. Once all the 5 epochs or 5 runs are done and model building is completed successfully by uploading the trained model to that S3 bucket, it goes through the model serving phase really quickly. And then I can, once all the stages are green, I can look at the run output again. And instead of 97.68, Let's see if we were able to achieve a higher model accuracy, 98.3. So that is better than the last run. So this is how you can do like hyperparameter tuning using Kubeflow pipelines and run your own experiments. Again, as you saw, the data scientists didn't need to interact with Kubernetes at all. Everything has been automated for them by the platform teams, and the platform teams were able to provide a self-service experience when it came to enabling data scientist teams. That's it for this demo. Thank you for watching.